Hey there folks, Dr. Saul, the solving surgeon, back talking to you about solving equations with variables on both sides. Now I have a question. Where does a boat go when it's feeling sick? To the dock.
Okay, let's review a couple things real quick. First, a variable. That's a symbol, usually a letter, that can be any given value. So here you can see we have an equation, and x is going to be our variable. It represents any given value. You can plug in any number for x and then solve it and see if that value is a solution to this equation. Or you could solve this for x, get x by itself to determine what value of x would make this equation true. A constant is a specific number. So if we're looking down here, any number that you see, that is a constant. Okay, it's just another word for a specific number. A coefficient is a number that's placed in front of and multiplied to a variable. So here our variable x is multiplied to this number 3, and that 3 out front is called a coefficient. It's a special type of constant. Solving equations. When you are solving equations, our goals are to simplify, move, solve. We simplify each side if possible. After you've simplified each side, then you move the variables to the left side of the equation. After that, you're going to move the constants to the right side of the equation, and then that gives you your answer. That's how you solve for your specific variable.
What did the patient who swallowed a pillow tell their doctor? I'm feeling a little down in the mouth. It's example time.
Example 1, to solve the given equation. So simplify, move, solve. Step 1, simplify both sides. This has an x, this does not. This has an x, this does not, so we can't do anything. Next, we move variables to the left side. So all the variables have to go to the left side. So this is going to stay here, right, this 5x, but this x is on the right side of the equation, so it has to go to the left side. In order to do that, this is positive x. I'm going to subtract x from both sides of the equation. Now I do that because now these are going to cancel each other out. And over here, I have 5x minus 1x, and that gives me 4x. Now all my variables are on the left side of the equation, so I move to step 3. Constants need to go to the right. I start with anything added or subtracted to our variable, so this minus 1 has to go to the right. How do I do that? I do the opposite. I'm going to add 1 to both sides of the equation, because whatever you do to one side, you have to do the other side. So this negative 1 and 1 cancel each other out, and I'm left with 4x over here is equal to 15 plus 1, 16. Now, to get x all by itself, constants need to go to the right, so this 4 has to go to the right. How do I do that? This is 4 times x, so I do the opposite, the inverse. I divide both sides by 4, and I do that because now these cancel each other out, and over here 16 divided by 4 gives me 4. Now remember, anytime you solve an equation, you can check your answer. You can take this 4, plug it in here and here, and both sides of the equation should be equal. Part B, we have 2b plus 4 is equal to negative 18 minus 9b. Simplify, move, solve. That's how you solve an equation. So first, simplify both sides. Done and done. This has a b, this doesn't. This has a b, this doesn't. So we can't combine anything. Next, variables need to go to the left side of the equation. So here, this negative 9b has to go over here. How do I do that? Well, it's minus 9b, right? So do the opposite, the inverse. I add 9b to both sides. These then over here cancel each other out. That's why we did that. And over here, 2b plus 9b is going to be 11b. Now I have my variables on the left side of the equation, so I got to move my constants to the right. I start with anything added or subtracted to my variable, so that would be this plus 4. I do the opposite, the inverse. I subtract 4 from both sides of the equation to move that to the right. Now these are going to cancel each other out, and negative 18 minus 4, I change it to adding the opposite, so it's going to be negative 18 plus negative 4, so it's going to be negative 22. To get b all by itself, I continue with step 3. I get my constants to the right, so this is 11 times b. How do I move that over here? I'm going to do the opposite, the inverse. I divide both sides by 11. Now these are going to cancel each other out, and I'm left with b is equal to negative 2. Again, always check your answer. Plug in negative 2 here, plug in negative 2 here. You should get the same thing on both sides of the equation.
You can call me Dr. Feelgood about doing math problems. You try.
Okay, so we're solving equations again. Simplify, move, solve. Step 1, simplify both sides. Done and done. This has a q, this does not. This has a q, this does not. So we can't simplify anything. Next, the variables need to go to the left. So this 4q has to go over here. How do I move it to the other side of the equation? Since it's positive 4q, I do the inverse, the opposite. I subtract 4q from both sides. These are going to cancel each other out. And over here, 5q minus 4q is going to give me 1q, or just q. Now, since I have my variables on the left, step 3, I got to move my constants to the right. Start with anything added or subtracted to my variable, so that would be this plus 3 right here. Again, it's positive 3, so what I'm going to do is I'm going to do the opposite, the inverse. I subtract 3 on both sides. These are going to cancel each other out, and I'm left with q is equal to 6, and I'm done. Again, make sure you check your answer. Plug in that 6 for q here and here, and make sure both sides of the equation are the same. Part B, simplify, move, solve. Step 1, simplify both sides. Done and done. This has a C, this does not. This has a C, this does not. So we can't simplify. Step 2, we need to move the variables to the left. So I'm going to start by moving this positive C to this side. How do I do that? Since it's plus C, I do the opposite, the inverse. I subtract C from both sides of the equation. The positive C and the negative C are going to cancel each other out. Over here, negative 3C minus C is the same thing as negative 3C plus negative C. So negative 4C. Now I have my variables on the left. So step 2 is done. Step 3, constants go to the right, and I start with anything added or subtracted to my variable. So this minus 12, I move to the other side. How do I do that? Do the opposite, the inverse. I add 12 to both sides. These are going to cancel out, and I'm left with negative 4C is equal to, and now what is negative 5 plus 12? What is 12 minus 5? That's going to be 7. So positive 7. Now all that's left is getting this negative 4 to the right. How do I do that? It's negative 4 times C. So I do the inverse. I divide both sides by negative 4. These are going to cancel each other out. I'm left with C is equal to negative 7/4. You could write your answer as a decimal as well. Again, it just depends how your teacher prefers you to write it. Example 2, doing the same thing. Simplify, move, solve. Start with simplify. Can we simplify this side of the equation? Yes, this 2 is outside the parentheses. And since we cannot combine what is inside the parentheses, again, this has A, this does not. That's why we can't combine it. What we need to do is distribute this 2. So I'm going to distribute the 2 here and here. If I multiply the 2 times the 8A, it's going to give me 16A. If I multiply the 2 times the 20, it's going to give me 40. So step 1 is done. Step 2, variables need to go to the left side of the equation. So I need to move this negative 24A to the left side of the equation. How do I do that? It's negative 24A, so I do the opposite, the inverse. I add 24A to both sides. These cancel out, and then 16A plus 24A is going to give me 40A. Now I have 40A plus 40 is equal to 0. So what I need to do is now get my constants to the right. Step 3. I start with anything added or subtracted to my variable. So I'm going to start with this plus 40. I do the opposite to move it. I need to subtract 40 from both sides. These cancel out, and I'm left with 40A is equal to negative 40, because 0 minus 40 gives me negative 40. I now have 40A is equal to negative 40. So to get A all by itself, it's 40 times A. So I got to do the opposite, the inverse. I divide both sides by 40. These cancel each other out, and then negative 40 divided by 40 is going to give me negative 1 as my answer. Part B, I have 7 times the quantity, 6 minus 2A, equals 5 times the quantity, negative 3A plus 1. I'm simplifying, moving, solving. Step 1, simplify. How do I simplify this side? Well, can I simplify what's in here? No, this has an A, this does not. But I can simplify with this 7 that's multiplied out front, so I can distribute that here and here. Same thing over here. Can I simplify what's in here? No, this has an A, this does not. But I can distribute this 5 here and here. So let's go ahead and do that. 7 times 6 is going to be 42. 7 times negative 2A is going to be negative 14A. 5 times negative 3A is negative 15A. And then 5 times 1 gives you 5. Boom, done, simplified. Now step 2, variables need to go to the left-hand side of the equation. So this negative 15A that's on the right side of the equation has to move over here. How do I do that? Well, it's negative 15A. So what I need to do is I need to do the opposite, the inverse. I add 15A to both sides of the equation. These then cancel each other out. And then over here, negative 14A plus 15A is going to give me positive 1A. Now I have my variable on the left side of the equation. So I need to move to step 3. Constants need to go to the right. So anything added or subtracted to my variable, I move first. So this positive 42, I need to move to the right side of the equation. How do I do that? Well, it's positive 42, so I need to subtract 42. So these cancel each other out, and then 5 minus 42. So I'm going to do 42 minus 5, and that's going to give me 37. Now, since this is the bigger absolute value, I take that sign, and it's going to be negative 37. Again, check your answer. If you're doing a test or a quiz, plug it back in. Make sure both sides of the equation are equal.
What's a physician's favorite drink? That's going to be Dr. Pepper. You try.
Okay, so again, we're simplifying, moving, solving. So we start with simplifying. Can we simplify this side of the equation? No, this has a y, this does not. What about this side? Well, in these parentheses, this has a y, this does not, so we can't simplify that. But we do have a negative 12 multiplied out front, which we can distribute. So we're going to distribute that right now. Negative 12 times 5y is going to give me negative 60y, and then negative 12 times negative 6 is going to give me positive 72. Now that I've simplified both sides of the equation, I move to step 2, which is moving my variables to the left. So I start with this variable on the the right, negative 60y. So what I'm going to do to move it, I'm going to do the opposite. Add 60y to both sides of the equation. That way these cancel out. And over here, negative 68y plus 60y is going to give me negative 8y. Now that I have this, I got my variables on the left, I'm going to move to step 3. Constants need to go to the right. I start with anything added or subtracted to my variable, which is this plus 4. I need to move that over here. How do I do that? Do the opposite, the inverse. I subtract 4 from both sides of the equation. These cancel out. 72 minus 4 is going to give me 68. Now, last constant I got to move is this negative 8. Since it's negative 8 times y, what I'm going to do is I'm going to do the opposite, the inverse. I divide both sides by negative 8. These cancel out now, and then 68 divided by negative 8. You can simplify that as an improper fraction, or you can just realize that it's going to be negative 8.5. Again, check your answer. Plug it back in. Make sure both sides of the equation are equal. Part B, I have 2r minus the quantity 5 minus r is equal to 2 times 6.5 plus r. Again, simplify, move, solve. That's how you solve an equation. So first, we need to simplify. Can we simplify this side? Inside the parentheses, 5 minus r cannot be simplified. But what's happening here is I have a negative 1 that is multiplied out front of these parentheses. Anytime you see a minus and then parentheses, you're really multiplying what's in the parentheses by negative 1. So I actually have to distribute that negative 1 to the 5 and the negative r. Same thing over here. Since I have 2 times this quantity and this quantity cannot be simplified, I actually have to distribute this too. On this side, I get 2r, and then the negative 1 times 5 gives me negative 5, and then negative 1 times negative r gives me positive r. Over here, 2 times 6.5 gives me 13, and then 2 times r gives me 2r. It looks like I've simplified both sides, except for the fact that over here, I have 2 like terms. I have 2r and r, which I can still simplify. So I'm going to use the commutative property, put them next to each other, and once I've done that, I can now simplify. What's 2r plus r? That's 3r. Sweet. Now that I've simplified both sides of the equation, I move to step 2, which is moving my variables to the left. So how do I do that? This positive 2r needs to go over here, so I subtract 2r from both sides. These then cancel each other out, and 3r minus 2r gives me r. Now I have r minus 5 is equal to 13, so step 2 is done. Step 3, constants need to go to the right, so this negative 5 has to go over here. How do I do that? Do the opposite. Add 5 to both sides. These cancel out. I'm left with r is equal to 18. Remember, you can always check your answer by plugging 18 in for r here, here, and here. Make sure you get the same thing on both sides. Now there are 2 special cases when you have variables on both sides of the equation. If you solve an equation and the variables cancel out entirely, your answer will be one of the following things. So if you solve an equation and you move the variables to the left side of the equation, but they end up canceling out, you're either going to get no solution or infinitely many solutions. No solution occurs when an equation simplifies to 0 equals a number or a number equals 0. So here's how this works. 2 plus 4q is equal to 2 times the quantity 4 plus 2q. So you treat it like any other equation. Simplify, move, solve. So we start by simplifying both sides. This side is already simplified. This has a q, this doesn't. Over here, inside the parentheses, this has a q right here. This does not. So that's simplified, but we have a 2 multiplied out front, which we can distribute. Once we have done that, step 1 is done. Step 2, we need to move the variables to the left. So we have on the right side this positive 4q. To move it to the left side of the equation, I subtract 4q from both sides. Now these cancel out. Also over here, these cancel out, which is kind of weird, right? That never happens. So now we have 2 is equal to 8. Right away, you can see that something's wrong, right? 2 is not equal to 8. But if you needed to really simplify this further, you can move the constants to the right and subtract 2 on both sides, and you get 0 is equal to 6. Now again, 2 does not equal 8. 0 does not equal 6, which means that your answer is no solution. On this side, you get infinitely many solutions when an equation simplifies to 0 equals 0. So if you were to solve this guy and you get 0 equals 0, your answer is infinitely many solutions. So let's see how this works. Simplify, move, solve. Can I simplify this side of the equation? No. Can I simplify this side? Well, I can't simplify what's inside the parentheses, but I can distribute that too, here and here. Once I've done that, next step would be to move the variables to the left. So I move this positive 4q over here by subtracting 4q on both sides. These cancel out. And these cancel out, which is kind of weird. So I'm left with 2 equals 2. Again, right here, you could tell that this is going to be infinitely many solutions because 2 does equal 2. Just like over here, 2 did not equal 8. So we knew that was not true. But if you needed to simplify it further, just for clarification, you can move your constants to the right by subtracting 2 on both sides and getting 0 is equal to 0. Since you get 0 equals 0 or 2 equals 2, you know your answer is infinitely many solutions. That means no matter what number you plug in for q here, as long as you plug in the same number over here, both sides will turn out equal. Example 3 says solve the given equation. So here, simplify, move, solve. First step would be to simplify. Can we simplify this side of the equation? Well, we can't simplify what's inside because this has a y, this doesn't, but we can distribute this 1/2. Normally I tell you to get rid of the fractions, but here, since it's just 1/2 and you're distributing it, 1/2 times 10 is going to be 5y, and then 1/2 times 4 is going to be 2. Now, we have simplified. So step 2, we need to move the variables to the left. So let's do that. We move our 5y that's on the right side to the left side. Since it's positive 5y, we subtract 5y from both sides. These cancel out and these cancel out. So what happens is we're left with 2 is equal to 2. So right away, you already know this is going to be infinitely many solutions. But if you wanted to, you can also subtract 2 on both sides, moving our constants to the right, and we get 0 is equal to 0, which again confirms that it's infinitely many solutions. For part B, we're again solving an equation, so we simplify, move, solve. First, simplify. Can we simplify what's in the parentheses? No. This has a k, this doesn't, but we can distribute that too. Just like over here, we can't simplify what's in the parentheses because this has a k, this doesn't, but we can distribute the 4. So let's do that. We distribute the 2 and the 4, and we end up getting 4k minus 2 is equal to 4k minus 8. Next, step 2, we need to move the variables to the left. So this 4k has got to go to this side. How do I do that? Well, it's positive 4k, so I do the opposite. I subtract 4k from both sides. These both cancel out, and I'm left with negative 2 is equal to negative 8. Right away, you know this is not right, so you can write no solution. But if you needed further clarification, you can add 2 to both sides to get our constants to the right, and we get 0 is equal to negative 6, which it is not. Therefore, your answer is no solution.
Who's the only physician that cures you with beats? That's gonna be Dr. Dre. You try.
Okay, so again, solving an equation, so we simplify, move, solve. Can we simplify this side? Can't simplify what's in the parentheses, but we can distribute that negative 2. Over here, this is already simplified. This has a c, this doesn't, so we're good. So let's distribute the negative 2. Negative 2 times negative c is going to be positive 2c, and then negative 2 times negative 12 is going to be positive 24. Now again, I need to simplify, move, solve. So I simplified, now I need to move. Move the variables to the left. So this 2c has got to go to the left. How do I do that? Since it's positive 2c, I subtract 2c from both sides. These cancel out, and these cancel out. So I'm left with 24 is equal to negative 12, which it is not. But if you didn't know that, what you can do is simplify this further, move the constants to the right, like you're taught for step 3. So I subtract 24 on both sides, and I'm left with 0 is equal to negative 36, which it is not. So therefore, your answer is no solution. On this side, simplify, move, solve. Can I simplify this? Not inside the parentheses, but I can distribute the 3. Can I simplify this? Well, not inside the parentheses, but I can distribute that 1.5. So I'm left with, when I distribute, 3m plus 4.5 is equal to 3m plus 4.5. Now again, right away, you can see, oh, that's the same thing on both sides. So right away, you already know this is going to be infinitely many solutions. If you didn't see that, keep solving. Step 2, move the variables to the left. So I subtract 3m on both sides, because in order to move this positive 3m, I got to do the opposite, the inverse. I subtract 3m on both sides. They end up canceling out on both sides. I'm left with 4.5 is equal to 4.5. Again, right here, you can see, oh, my answer is infinitely many solutions. If you didn't see that, keep simplifying. Move my constants to the right with step 3. So I subtract 4.5 from both sides. They both cancel out. I'm again left with 0 is equal to 0, which signals to you one more time that your answer is infinitely many solutions. Now let's do our word problem. So it says, on the way to your family vacation in Texas, you drive at an average speed of 65 miles per hour on the highway. On the way home, there is more traffic, so you drive at an average speed of 55 miles per hour. Because of this, the ride home takes an hour longer than the ride there. If distance is equal to rate times time, how many hours did it take to drive there? So it's a word problem, so the first thing we need to do, define our variable. What are we trying to find? Well, it says, how many hours did it take to drive there? That's the question. So how many hours? Let's say h is going to be the number of hours it took to drive to Texas. That's what we're trying to find. Next, we need to write our equation. How do we do that? Well, there's a couple things in this problem. We're given a bunch of information. We're also given that distance is equal to rate times time. So this must be important. What do we know about the distance from your house to Texas and from Texas to your house? It should be the same, right? You're driving the same distance from your house to Texas that you are from Texas to your house. Since we know distance is equal to rate times time, what we can actually do now is we can plug in the rate from your house to Texas times the time from your house to Texas is equal to the rate from Texas to your house times the time from Texas to your house. Now we have something we can work with. Rate to Texas. Was there a speed given that we drove to Texas? Yes, 65 miles per hour. So here we can plug in 65. Here, the rate from Texas, 55 miles per hour. We can plug that in. And then the ride home takes an hour longer. The time to Texas, we defined as h. So that is going to go here. And then since we just saw that the ride home takes an hour longer, here, the time from Texas, we do h plus 1. Now we have our equation, so what we're going to do is we're going to simplify, move, solve. Step 1, simplify both sides. 65 times h becomes 65h. Over here, I can't simplify what's in here because it says the h and this doesn't, but I can distribute the 55 to the h and the 1. So I end up getting 65h is equal to 55 times h plus 55 times 1. Now I need to do step 2, move the variables to the left. So this 55h, this positive 55h has to go over here. How do I do that? It's positive 55h, so I do the opposite. I subtract 55h from both sides. These cancel out, and then 55h taken away from 65h is equal to 10h. Now I have 10h is equal to 55. Step 3, I need to move the constants to the right, so I divide both sides by 10. These cancel out, I get h is equal to 5.5. Because it was a word problem, you need to answer as a sentence. Do not leave your answer like this. What does 5.5 mean? It means that it took 5.5 hours to get to Texas.